Hi everyone, I'm just going to quickly show you how to enable traffic engineering on our interior routing protocol. For this lab, we'll be using OSPF. We're going to enable MPLS, enable our RSVP signaling using traffic engineering. We're going to create an LSP across our network. We are going to enable Fast-Reroute using the one-to-one method. Another thing I want to talk about is I just passed my MPLS exam, so my little bit of advice I can give you guys is make sure you understand your Fast-Reroute using one-to-one, the differences between that and facility bypass, the difference between a node and a link protect detour, and make sure you really understand your path messages and your reserve messages, as well as the admin groups and the difference between that using an admin group and SRLG and when it's more appropriate to use an admin group. So let's go ahead and start here. So we have no MPLS enabled on router 5 or traffic engineering. Everything else I've pre-configured across my network here, equal path using OSPF. So we're going to go ahead and start with our router 5. So we're going to go ahead and drill into OSPF area 0. So you can see traffic engineering is not enabled in OSPF. So all we have to do is at your OSPF level just add traffic engineering. Traffic engineering will create a type 10 LSA, which is an opaque LSA. So if you do show router OSPF opaque database, you can see all my other routers 1, 2, 3, 4, 5, and 6 are advertising opaque databases. And that's what's used as a traffic engineering database, which is what CSPF will reference. So let's go enable MPLS. So configure router MPLS. Your system interface by default is populated in here. So we'll add our interface to router 1, our interface to router 3. So we will no shut this, go back, and our signaling will be RSVP. So anything you add to MPLS configuration will populate into the RSVP configuration. So there it is. So make sure you no shut that. Show router RSVP interface. There's no active sessions. Make sure for your exam portion you know the default modes of RSVP and LDP. RSVP is downstream on demand for signaling, so that's why there's nothing here. LDP is downstream unsolicited, which will just flood its labels to its next hop neighbors. Alright, MPLS. We'll go ahead and so now we're going to signal an LSP across the core and to our router 6. So we'll create a path. This will be a loose path using OSPF. No shut in. It's that simple. There it is. There's our path. No constraints set on it. And no link coloring, nothing. So we'll go ahead and do our LSP to router 6. Do the far end. This does not have to be the system IP of the node. Remember that. That will enable CSPF. It's required for constraint-based routing. I'll do our path, so our primary path. We'll reference our loose path. Then we'll turn on Fast-Reroute one-to-one. By default, this is set to node protect. If you would like to use link protect, you basically all you have to do is say no node protect here. So here is our LSP. That's that simple. So we will no shut it. This will signal. Show router MPLS LSP to router 6. We'll do our path detail. Up, up. That's great. Another thing is make sure you get familiar with these legends. Detours available, detours in use, node protected. you want to be able to glance and see what's happening, right away when you're looking at a path detail for an LSP in case there's an outage going on or a break somewhere. So here's the path. Router 5 is going router 5, router 1, router 2, router 6. Again, these are equal paths, so remember that. So path message. Okay, so detours available, node protected. So if the link between router 5 and router 1 were to go down, this link can be node protected, router 5, router 3, router 4, router 6. It would just avoid this, and since this is it would use the lowest metric, so it'll just go to router 6 to the merge point of the original LSP. If the link between router 1 and router 2 were to go down and it's signaled 5, 1, 2, 6, router 1 will node protect router 2, therefore going 1, 3, 4, 6. If the link between router 2 and router 6 goes down and we have node protection enabled, this detour available, what will happen is it will create a link protection. So router 2, router 4, router 6 back to the merge point. So even though it's set to node protection, when it's the last hop away, if it's able to do a link protect, it will use it. So now let's see what happens. So we're going to have router 2 be the failure node. And we're going to shut the interface or the port going back to router 1. Therefore, router 5 and router 1 is going to have to come up with a fast reroute solution to get to its destination of router 6. So here's my router 2. Again, this is my path detail. And so router 2 to router 1 is port 111. So okay, so we'll just go ahead and shut this port down. This is basically emulating a break between that connection. So let's see what Fast-Reroute will do. So it does take a second here. If I had BFD enabled, this might be a different story here. See if we can catch it. So we should see a pound sign come up here saying that the protection's in use. And there it is. So let's see what's happening. 5, 1, 3, 4, 6. Point of local repair is router 1. Here's the pound. Legend says detours in use. Now this should resignal 5, 3, 4, 6, 5, 3, 4, 6. After fast reroute, the LSP tried to find a better path, and it did. So it switched over to it, and this is all make before break. Make sure you get familiar with that as well. And so yeah, that was just a quick rundown of Fast-Reroute. If you have any questions or anything, shoot me an email, drop a comment. Thank you for watching.